Hello, this is Dr. Mears, and today we are going to be learning about quadratic models in applications and interpretations, SL1. A dolphin jumps above the surface of the ocean, as seen in this picture here. The path of the jump can be modeled by the equation f of x equals negative 0.1x squared plus 2x minus 3.4. Let's look at what the x and f of x represent. X represents the horizontal distance in meters that the dolphin has traveled from the point where it left the water to where it went into the water. So the horizontal distance is here. So this is the x-axis, and this is going to be the distance. Okay, f of x. F of x represents the vertical height in meters of the dolphin above the surface of the water. This is the f of x. This is the height. So how far the dolphin has traveled represents x in meters, and how high the dolphin has jumped is the height in meters. So we're putting some background information using our model to represent the distance and the height of a dolphin jumping. This is represented as a quadratic function. Quadratic functions are polynomial functions where the highest exponent is 2. If you notice, this exponent is 2 here. I know x doesn't have an exponent, but that's because the little 1 likes to hide. So when you see an equation, a function, where your largest exponent, your highest exponent is 2, that is a quadratic function. Let's look at what the standard form is. Standard form, also known as general form in IB, is f of x equals ax squared plus bx plus c, where a does not equal 0, and the variables a, b, and c are all real numbers. That's what that fancy looking R is. So that's just saying that any number that we see that we've been using, -1, 2, 1.4, those are all real numbers. So your A is going to be a number, your B is going to be a number, and your C will be a number. We have to remember that this A cannot be 0 because then it would just cross that out. We can't have that. And again, this is known as standard form. It's in the form ABC, standard ABC. And in IB, it is known as general form, so I will be using general form moving forward in my videos. All right, let's keep looking. Let's keep exploring this topic. So the graph of a quadratic function is known as a parabola, and we're going to label some of the key points. This is actually our graph of the function that we just looked at. F of x equals negative 0.1 x squared plus 2x minus 3.4. So why don't we title this graph with our actual equation here? That is a nice title, a mathematical title. Okay, so now we know that this equation, when graphed, looks like a parabola. It's a curve. So please mention it as a curve. This is not a line, it's a curve. Let's look at some of the key points. We notice in this curve, it crosses the f of x axis, also known as the y. That's absolutely fine. We can interchange these, just means function. So if it's a true function, we can say f of x. And we have the x-axis. Okay, so this curve, if looking at it from left to right, we notice it crosses the f of x at this point 0, negative 3.4. This is known as our y-intercept. You could say f of x intercept, but more so than that, it's going to be called your y-intercept. Okay, let's keep looking. We notice that we have one point here where it crosses the x-axis. This point is known as the x-intercept. We also notice that we have another one here. Yes, so we have how many x-intercepts? We have 2 x-intercepts. One here and one here. And that's fine. Sometimes they might not have any. Sometimes they might have one, a double one. We'll get to that soon. But now we notice we have an x-intercept here and an x-intercept here. And we also have this point at the tippity top. This is called our maximum. Okay, so remember, this x-axis is the distance that the dolphin jumped. So it started here, it reached up all the way to our maximum, and then it came back down to the water. So this graph really represents a picture of what the dolphin's doing. Came all the way up, jumped out of the water, went all the way back down. And remember, this is how high, the height, and these are in meters. Okay, let's fill out some key features. So what do we find? Some key features. X-intercepts, where the graph crosses the x-axis. So let's label those. X-intercept is here, so the first one happens at 1.8760. And we do have another one over here at 18.124, 0. Perfect, okay. What's next? Let's look for the y-intercept. This is where the graph crosses the y-axis. I've even included the definitions for you. Y-intercept at 0, -3.4. Notice the x-intercepts have their y as zeros. The y-intercept has the x as 0. Okay, what else? Vertex. Now, vertex is known as either the maximum or minimum point. That's called a vertex. So for us, we had a maximum point. We had a height. We had the tallest point. This is the maximum, and it happened at 10,6.6. Okay. And we also need the equation of the axis of symmetry. This is an imaginary line that cuts the graph in half. So the axis of symmetry is an equation, and we're going to write it as x equals. So if we look, this graph, we can cut it in half all the way through. So there's this imaginary line that if we took this side, and if we folded it on the imaginary line, this side and this side would match up completely. And that happens when x equals 10. When x equals 10. This is x, this is f of x. So we're just going to write x equals 10. Now, this is the graph of a dolphin jumping. So I want to just point out two things. First, I want to point out how far did the dolphin jump. That's the first thing. How far did the dolphin jump? And I'm going to write that right here. How far and how we find that is we take the furthest 18.124, the furthest x-intercept. This is where he went back into the water because the water is down here. So we're going to be taking 18.124 and we're going to be subtracting where he started. He started at 1.876. And when we do that, we're going to get the distance it traveled from here to here. Makes sense. So let's take out our calculator. Let's do, whoops, I don't want that. Okay. Let's do 18.124 minus 1.876, and we're going to get 16.248. So 16.248 meters. That's how far it went. Okay, perfect. All right. And the other key feature is the height. How high did it jump? So let's put that up here because how high did it jump? How high did the dolphin jump? Okay, and if we look, remember, height is the f of x. This is the maximum. So this is the tallest point. So what we're looking for, since height is f of x, We're looking for the f of x. What is the f of x value? And that's 6.6. So 6.6 meters. That's how high the dolphin jumped. So it went 16.248 meters. That's how far. And it jumped 6.6 meters. That's how high it went. Okay, nice analyzing a graph. Let's look at one that's a little bit different. So now we're looking at another example, and we're just looking at the equation. I have no story to go behind this. We have f of x equals 3x squared plus 6x minus 4. Now this graph looks a little bit different. What do you notice? And I'm hoping you notice that it has a lowest point. The lowest point here, this is called a minimum. So it just got flipped around. Okay, do we also have other key features? Yes, what do you notice? We have an x-intercept here, right here. We also have another x-intercept here, because this is the x-axis. And here's our f of x-axis also. You can call it your y-axis, that's fine, because yes, you see that we have a y-intercept here. Okay, now that we labeled the key features on our graph, let's write them down. The first one you're going to have to find is the x-intercepts, where the graph crosses the x-axis. So we're going to write these points down. Negative 2.528, comma 0, and 0.528, comma 0. Okay. And the reason why I'm not using whole numbers is because we really have to get used to using these decimals. It's not going to be perfect all the time. Our y-intercept is nice though, isn't it? Y-intercept where the graph crosses the y-axis. Yes, it's 0, comma, negative 4. That was perfect. Our vertex. So our vertex, remember, it's a minimum. So now it's a lowest point of the graph. So it's a minimum. And that happens at negative 1, negative 7. Okay. And the equation of the axis of symmetry. Remember, axis of symmetry is this imaginary line that cuts the graph in half. So if we look, the imaginary line always goes through the maximum. And the imaginary line is always what the x-axis is, because it's right here. This is where the imaginary line goes through. So it's always the x number. And we have to make sure that we write it. It's a line. So we have to write x equals negative 1. You have to put down the x equals. If you just write the number, I will mark it wrong. And then we will be, you'll be like, well, it's the right number. I'll be like, no. The whole point is being able to write it as a line where it's x equals, because that's what it is. It's an imaginary line that cuts the graph in half. Okay, now that we labeled, now that we actually wrote down the points, let's look at our next example. And this next example is linking our prior knowledge to what we're doing now. And that's linking our linear and our quadratic together. So let's find the point of intersection between the curve f of x equals 3x squared plus 6x minus 4. That's the equation we just had, this curve right here. And a line, f of x equals x minus 2. And we're going to use our GDC. Remember, GDC is graphical display calculator. Now, before I bring out the graphical display calculator, we need to understand a little bit about the graph. And when we look at this graph, what I'm going to want you to notice is where the line crosses the curve. Okay? So we need to find the intersection. This is our first intersection point. I always read a graph from left to right. And from left to right, this line right here and this curve cross at this point. That's the first point they cross at. Where else do they cross? So if we keep going, good, they cross right here. So this curve and this line cross another time, and that's going to be right here. So on our calculator, we're going to need to find 2 points of intersection. Okay, 2 points of intersection. So now that you understand what we're looking for, we're ready to use our graphical display calculator. Here are your steps. The first step is to press y equals. Anything in bold here is what you need to press. So we're going to press y equals right here, y equals. Okay, we're going to put these equations in. Okay, so y equals, we have 3, this is your x button, and you can use the square button right here, 3x squared. Make sure you move over so you're not in that exponent spot anymore, plus 6x minus 4. You're going to push enter because we have another equation to enter. We have x minus 2. Now, once you entered both of those equations, we are ready to zoom. So we're going to press zoom, and I didn't write that there, zoom. So make sure you press zoom. I forgot that one, I'm going to fix it. Zoom, and then we need to go to standard. So zoom standard, because these numbers are small, we don't need to look at, we don't need to go to 100 on the y-axis. We just need a standard negative 10 by 10 graph. So I'm going to push number 6, and I'm going to give it a minute. There we go. There's the bell. And there's the graph. So if you notice, this graph is just a little bit more zoomed in because I'm going to actually be using this graph to help us with this one. All right, so we want to find points of intersection. So you're going to press the second button and then this trace button, and you're going to notice number 5 is intersect. So we're going to press number 5. Now you see the blinking dot. So this is what has to happen. It asks you for your first curve. We have to tell it which point we want to find first. So what I need you to do is use your left arrow button to move it to the side of this point. So I'm moving my blinking dot over here, and this is going to be my first curve because I want the calculator to know I want to be on this side of the graph, okay? And so we're on the curve and we're on this side, so it's going to help me find this point first. I'm going to press enter. I'm pressing enter, everybody down here, enter. Now it asks you for your second curve, and notice it's on the red line. And so the second curve, see where the blinky dot is here? I'm just going to go over just a little bit because what this does is it helps set up a boundary to tell the calculator I want to locate that intersection right there. So the little blinky dot right here, and this is going to be the second curve. I know it's not a curve, it's a line, but bear with me. I'm going to press enter, and it asks me, would you like me to take a guess? And guess what? You do. So you're going to press enter again. Notice, there it is, right here, that's our intersection point. Underneath, x is -2, y is -4. So this point is -2, -4. You have to write it in a point because it's an intersection point. So you take these two numbers and you write it as a coordinate. So their first intersection is -2, -4. Okay. Now, we located our first one, and I'm just going to write that down, -2, -4. And we're going to have a second one. Our second one is going to be here. So let's go back through the steps again. We don't have to put it in the, we don't have to put it in we don't have to press y equals because they're already there. So let's work back to the graph. Okay, second trace, we're looking for number 5. Now, we have to move the blinking dot over here. We have to tell it that we want this point now. So you need to use your right over arrow to get on that side of the graph. So I'm going to move it up here. It doesn't matter as long as it's somewhere over here on this line, on this curve, okay? So it's on the blue curve. So my blinking dot is here. So I'm going to say I'm up here. So this is my first curve. And I'm going to press enter. I'm pressing enter. Now it looks at the red second curve. So I'm going to move my over arrow button a little bit. And so I'm over here. And so this is going to be my second curve. So now I'm telling my calculator, I want you to find this intersection point. I'm going to press enter. I'm pressing enter, and it asks you, would you like me to take a guess? And I'm going to press enter again. There's your next intersection point. This point is 0.333. You can go to 3 significant figures, so just those 3 threes are fine. And then -1.67. So you have to take these two numbers, the x and the y and write it as an ordered pair. That's how I would like the intersection represented. So we have two. We have one here and one here, and so we're going to write those both down, 0.333 and negative 1.67. So those are our two intersection points. Using our graphical display calculator, making sure that we're locating them correctly. And that's how you find the two intersection points using your GDC. This has been a little introduction to parabolas and even using our prior knowledge to find intersection between a parabola and a linear equation. Thank you. Hope it helped.